Hello everyone. This PowerPoint is going to be on construction hazards. So a lot of it is some that information that we've already gone over in previous PowerPoints. Some of it is new, so just bear with me. It's not going to take too long. What are the objectives of this presentation? We're going to identify four major hazards, which we already know. Describe the ways to protect themselves from hazards. Learn how to select the proper PPE and apply safety procedures when working in or around trenches, electrical equipment, scaffolds, and power tools. Okay, so the major hazards of construction are falls, electrocution, being struck by falling objects, and trapped during excavation. We should all know that by now. So for the first one, falls, fall protection, conditions that required use of fall protection, and what are some options available to protect workers. So falls, we know, is the leading cause of fatalities in the construction industry. Conditions that are required use of fall protection. A fall from as little as 4 to 6 feet can cause loss of work, in some cases even death. When is fall protection needed? So walkways, ramps, open sides, edges, holes, excavations, roofs, wall openings, bricklaying, residential construction, pretty much there's so much areas. Fall protection and prevention options, we have safety nets, handrails, safety harnesses, equipment, guards, and fall protection systems must be in place before work starts. Personal fall protection system, it must be properly trained. Key requirements: no free fall more than 6 feet, must be inspected prior to use, and safety line must be able to support 5,000 pounds. Guardrails, top rail between 39 to 45 inches tall. Toe boards at least 3 inches tall. You have here in this diagram, you have the top rail, the mid rail, and toe board. Safety nets used to catch falling workers, also catch any materials, equipment, pretty much anything. Placed no more than 30 feet above the work area, and placed not more than 8 to 13 feet from the edge of the working area. Falling objects, hard hats are required at all times. Use of canopies is authorized, and barricade the area to prevent unauthorized entry. So to sum it up, a fall of 6 feet or more protection is needed. So use your fall protection on walkways, ramps, open sides, edges, excavation. Second, electrocution. Now we have electrical safety. So this section will discuss safety requirement, the hazard prevention and control, most common injuries, and the PPE associated with electrical work. How it works: electricity is a flow of energy from one place to another, requires a source of power, so generating station, power station, or portable generator, and travels in a closed circuit. Always assume that all power head wires are energized. Never touch a down power line. Never operate electrical equipment while standing in water, of course, and coming in contact with electrical voltage can cause current to flow through the body, resulting in electrical shock and burns. Serious injury or even death may occur. Electrical accidents, most frequent causes. So the most frequent is contact with power lines, lack of ground fault protector, missing ground on electrical cords, improper use of equipment, and improper use of electrical cords. Electrical accidents are caused by a combination of three factors: unsafe equipment and/or installation, workplaces made unsafe by the environment, and unsafe work practices. Exposed electrical parts: isolate the electrical parts, use guard or barriers, and replace any covers. shall be protected from abrasion, and all openings shall be closed to prevent access. Overhead power lines, usually not insulated, they carry extreme high voltage, and 40% of lineman deaths were caused by contacting a live wire with a bare hand. Overhead power lines, equipment that can contact power lines are cranes, scaffold, ladders, and scissor lift. So most common injuries: direct is electrocution or death, shock and burns, and indirect are falls. Most common injuries: electrical shock, electrocution. Electrical shock is received when electrical current passes through the body, can cause severe damage, death. You will get electrical shock if a part of your body touches an electrical circuit by touching a live wire and an electrical ground, touching a live wire or another wire at a different voltage. Most common injuries are burns. Most common shock-related injury: electrical burns, arc or flash burns. Thermal burns occurs when you touch electrical wiring or equipment that is improperly used or maintained, and very serious injury that needs immediate attention. Okay, most common injuries: falls caused by involuntary electrical shock, occurs on personnel working in elevated locations such as ladders and scaffolds, and may result in serious injury and or death. So PPE, as we know, should always be the first line of defense. Rubber gloves, rubber insulated work boots, hood sleeves, or blankets. Safety work practices: only qualified person should work on electrical equipment. Use special insulated tools when working on fuses with energized terminals. Don't use worn or frayed cords and cables, and don't fasten extension cords with staples, hang from nails, or suspended by wire. De-energize live parts before commencing work. Lock or tag out the circuits, or both. Inspect extension cords. Avoid contact with overhead lines. Avoid wet conditions, and check switches and insulation. So electrical equipment must be listed and labeled, free from hazards, used in proper manner. If you use electrical tools, you must be protected from electrical shock and provided necessary safety equipment. So, are we digging on a trench? Are we working on a trench or digging your own grave? So now we're going to go into trenches and excavation hazards. So the risks of excavation, I'm going to discuss that. How to protect employees from cave-ins. Factors that pose a hazard to employees working in excavation, and the role of the competent person. So a lot of this is just review from the previous lectures we had. So most hazardous construction operation, cave-ins are the greatest risk, and most accidents occurred in 5 to 15 feet deep. Employees, should be protected from cave-ins by using a well-designed protective system. Systems must be able to support expected loads to the system. A well-designed system will have a correct design of sloping and benching systems, something that we touched upon in last PowerPoint, and correct design of support systems, handle materials, and equipment. Protect employees from potential cave-ins, slope or bench sides of the excavation, and place the shields between the side of the excavation and the work area. So this is photos of inadequate worker protection right here. Factors that pose hazards to employees: soil classification, the depth of cut, water content of the soil, changes due to weather and climate, other operations in the vicinity. So, types of protection: trench shield. A trench shield was built around this work area. Hydraulic jacks, easily dropped in place and adjusted. Trench pins installed in case of hydraulic failure. Oop, what happened here? Okay. Um, Egress systems. So, a stairway, ladder, or ramp must be present in excavations that are 4 or more feet deep and within 25 feet of employees. So this photo shows that this is useless right here, having this ladder. It does not meet requirements of any standard, and must extend 3 feet above the excavation. This is definitely not even reaching the top of the excavation. So, competent person. So, must have had specific training in and be knowledgeable about soil classifications, the use of these protective systems like trench boxes, and the requirements of the standard. Must be capable of identifying hazards and authorized to immediately eliminate the hazards. A competent person must make daily inspections of excavation areas around them and the protective systems, and before the work starts and as needed. After rainstorms, high winds, or other occurrences which may increase hazards. When you can reasonably anticipate an employee will be exposed to hazards. So, to sum this up, the greatest risk in an excavation is a cave in. Employees can be protected through sloping, shielding, and shoring the excavation. A competent person is responsible to inspect the excavation daily, and other excavation hazards include water accumulation, oxygen deficiency, toxic fumes, and mobile equipment. And that's going to be it for construction hazards. I hope a lot of this stuff was just, you know, a refresher to what we've already learned and what you have already known. So yeah, once again, class, if anyone has any questions on anything, just send me an email. Um, and again, I've got emails on the presentation requirements. Where you're still gonna be doing the assignment, which is the job hazard analysis. Um, the specific the specifics on the job hazard analysis are all in your syllabus under the presentation. So take a look at that. It's not uploaded to Blackboard anywhere. Just it's just in the syllabus, all the information. But if you have anything specific to ask, just again send me an email and I'll get back to you. And then we will also have the final exam, which is going to be similar to how I distributed the midterm exam. And that's going to be all. Thank you. Bye.